The periodic table is the arrangement of the elements in order of increasing atomic number that shows elements grouped together with other elements of similar properties to form a repeated pattern. It is the most important tool for chemists and one of the most important discoveries in science because it is a guide to the properties and behaviors of an element. There's no memorization here. All you got to do is remember the patterns. This allows chemists to predict physical and chemical properties of undiscovered elements, and they can predict how elements will interact with other elements. It works because it's based on the structure of the atom. An atom is the smallest particle into which an element can be divided and still have properties of that element. So if you have a piece of gold, you cut it smaller and smaller, eventually you'll reach an atom of gold. An atom is believed to have protons and neutrons in the nucleus, and electrons orbiting around the nucleus in shells. Here is the periodic table. There are 118 known elements put into 18 columns called groups and 7 rows called periods. Let's look at one of these elements, chlorine. We can learn a lot about chlorine just based on the location of chlorine on the periodic table. We know it is a very reactive nonmetal that is a gas at room temperature and is harmful to humans. We can also get information about its atomic structure. The atomic number for chlorine is 17. This is the number of protons. It's the identity of the element. The atomic mass for chlorine is 35.453 atomic mass units. This is the mass of the nucleus and abbreviated with an A. It is actually a weighted average of all the isotopes of chlorine. Let's diagram chlorine. The atomic number is 17. There are 17 protons. If the atom is neutral, then there are also 17 electrons. To determine the number of neutrons, we round the atomic mass and subtract the number of protons. 35 minus 17 equals 18 neutrons. The protons and neutrons are in the nucleus, while the 17 electrons are in shells surrounding the nucleus. 2 electrons in the first shell, 8 in the second shell, and 7 in the third shell. What we want to do is predict the properties of elements based on their locations on the periodic table. Specifically, what is the relationship between the atomic mass and the atomic number? Let's begin by collecting some data. We will fill out this chart together by filling in the element name, element symbol, atomic number, and atomic mass. You can then do additional elements. We will plot the data on a graph and determine the relationship. Let's begin with hydrogen. The element symbol is H, the atomic number is 1, the atomic mass is 1.00. The next element has the symbol C, atomic number 6, atomic mass 12.01. This is, of course, carbon. Sulfur has atomic number 16, atomic mass 32.07. The symbol is S. Titanium has the symbol Ti. The atomic mass is 47.87 atomic mass units. The atomic number is 22. The symbol for nickel is Ni. The atomic number is 28, and the atomic mass is 58.69 atomic mass units. You can do the remaining elements. Pause the video and fill in the chart. We will then graph the data together. Here's our atomic mass versus atomic number graph. Atomic number is the x variable on the horizontal axis, and the atomic mass is the y variable on the vertical axis. Let's plot the data for the 5 elements that we did together. You can plot the other 4 elements. Hydrogen has atomic number of 1, atomic mass is 1.00, which is basically 1. Carbon, atomic number is 6, atomic mass is basically 12. Sulfur, atomic number is 16, atomic mass is basically 32. Titanium, atomic number 22, atomic mass is basically 48. And nickel, atomic number 28, has atomic mass of basically 59. Once you have carefully plotted all the remaining points, we can look for a relationship in the data. As the atomic number increases, the atomic mass increases as well. The points are almost all on the same line, so that can tell us it's a positive linear correlation. Now for the good stuff. Let's use our graph to predict the atomic mass of an element if we know its atomic number. Let's try chromium. Atomic number is 24. So based on our graph, when x equals 24, y is about 51 atomic mass units. Let's see if we can be more accurate though. Let's input our data into a graphing calculator and have the calculator do what calculators do best, calculate. We can have it calculate the line of best fit, and we will use that line for our prediction. Right now, in L1, I'm inputting all the atomic numbers for the elements that we worked out. L2 will be the atomic masses for all those elements. Now let's have the calculator crunch the numbers and calculate the line of best fit using the equation y equals mx plus b. There we have it. A, or m for us, is 2.23, while b is negative 1.75. This means that the equation for the line of best fit for our data in the form y equals mx plus b is y equals 2.23x minus 1.75. We can now predict the atomic mass, which is y, of an element because x is the atomic number. Let's use this formula to predict the atomic mass for chromium, atomic number 24. Remember, based on our graph, we thought it would be about 51 atomic mass units. We will plug the atomic number 24 into x in the formula, and the answer we get is 51.77 atomic mass units. That's pretty close to our estimate, but how close is that to the true value for the atomic mass of chromium? Well, for that, we need to look at a periodic table, and we can see the information right there. 51.996 atomic mass units. Looks like we were pretty close. Let's work out our percent error to see how close we really were. We take the true value, 51.9961, and subtract our calculated value, 51.77. We divide it by the true value and multiply it by 100. We are only off by 0.4%. That is fantastic. So our equation seems to be pretty accurate, at least for the first 31 elements that we used to collect our data. Try some other elements. You can use the graph to predict the atomic mass, then the formula to predict the atomic mass as well. You can compare it to the true value on the periodic table and work out your percent error.